Okay, guys, I'm just going to do some notes real quick for you before we do the acceleration concepts assignment here. So what I want to specifically talk to you about is not exactly having to do with acceleration. It actually has to do with math functions, but this really helps us to a little bit better understand what happened on the lab that we did on Friday. So I've told you specifically that there are four shapes that you're going to see in this particular course. Let's not do that one there. Actually, let's do that one last. And then we'll do that one last. Okay. Basically, what I want you to get down in your notes right now, if you haven't already, I want you to write these down again. It's kind of confusing. Let's see if we can hear that more. But let's put three columns up here. So we have the shape that you're going to see, okay, its name, and function. Okay. So anytime you see this shape in mathematics or in science or anything like that, it means that there is a very specific name that goes with all of these. That one's easy. We can just name these. I mean, you know this one pretty well. This is called a few things. Obviously, it is a line. It is linear. It is direct. There's a bunch of things, but we're just going to go ahead and call it a linear function. Okay. This one right here, if you see this curve up, it kind of depends exactly how it curves up, but the specific name that we're going to use in here is parabolic. This right here also has a bunch of different names, but we are going to use actually hyperbolic. The other name that you might know for the sake of ACT, SAT, anything like that is this is also called inverse or indirect. And this right here is the square root function. Now, if they make any of these particular shapes and they have these particular names, a nice thing that goes hand in hand with that is they have a very particular function. Okay. For linear, you are used to y equals mx plus b. We are actually in here not even going to worry about the b. We're just going to say y equals mx. Now, a couple things about that before we continue. Okay, we've talked a little bit about kind of invisible things that are on a variable even though you don't see them. One of which is you can always divide by 1. That's technically always there. You can always put a plus next to it. That's technically always there. But the one I wanted to address today is if you see a variable by itself, it is technically to the first power right there. So in a linear function, we have the y and the x that are both to the first power. Okay, that's important because as we head down to the parabola, its equation is y equals mx squared. The y is still to the first, but specifically the x is squared. So if you were to see this shape, you know what's specifically going on with the variable in that particular case. The hyperbolic function, I'm going to write it two ways, as should you in your notes. I'm going to write it the easier way, y equals m divided by x. The other way I'm going to write it, though, real quick, is just to show you what I've been talking about here, and that is y equals m times x to the negative first. Okay? Again, it might be confusing to see the x here because you go, it's to the first, I don't see anything. But the fact that it is underneath the fraction actually means it is x to the negative first. Is that like practically impossible to see? If I made that way too small, I apologize. I don't know if that's any easier. Square root function, you can probably guess what its equation is, but let's go ahead and put it up here anyway. It's y equals m times the square root of x. But once again, I'm going to write it a second way. Y equals m times x to the 1/2. Because once again, what you see is it's specifically what happens to the x variable that decides what the shape is of every single one of these functions. So the question that you might have then is, all right, great. This seems like random stuff. Well, what am I going to do with it? Okay, well, you can do a couple things with it. For starters, you can look at an equation. Okay, I could see like a equals b times c, and I could actually then ask you, if I make that my y variable, and that my x variable, what shape is it specifically going to make? Well, because I'm looking at the equation here, I can see that's to the first power and that's to the first power. I know for a fact it's going to make a straight line. On the other hand, if I had some random d equals e times f squared, and I were to graph d versus f, we actually get a parabolic function in that particular case because simply f is squared. So all you've got to do is look at what's happening. Now, on the other hand, actually what we're probably not going to do this as much, what you're probably going to do much, much more often is look at the graph. So let's imagine, if we will, what graph we got on Friday, and that was we graphed distance right over here when we get a capital D, and that was in centimeters. And we graphed time right down here, and that, of course, is in seconds. We got a graph that is parabolic. So all I want you to do is real simple then. If you got that, I want you to put a basic prediction of what the equation looks like. So specifically, I get distance equals some constant times time squared. And all I did to get that is I just saw it as a parabolic, and so I just used this equation. But instead of y, I put what's on the y, distance. And instead of x, I put what's on the x, time. Let's go ahead and practice just one more, okay? So if I were to see something like this, if I were to see, say, that's mass, and that's volume right there. Oops, not mass, my apologies. That would be pressure. And volume right here, and I were to get this shape, all I'm going to do is I'm simply just going to come over here and see that, okay, this is in fact a hyperbolic function. That is always its equation. So all I'm going to do is basically rewrite that again, except instead of the y, I'll write what's on the y, and instead of the x, I'm going to write what's on the x. As far as the constant m, we're just going to leave that alone for right now. So all we do is we write p is equal to m over v. And that's all you got to do for those. I do want to show you real quick, just as a reminder, I think we talked about a little bit of this one the other day, but you're going to do a decent amount of arrow diagrams when it's accelerating. So let's look at those just really quick, okay? Let's say I have a situation where a person is out moving. Originally, velocity initial is 3 meters a second, okay? And then I say acceleration is, I don't know, let's go 5 meters per second squared. All that means is that the first arrow I'm going to write is 3 meters over 1 second. Okay. Now this is the starting arrow right here. Okay, this is how fast we're going at the beginning. So in a weird way, I want to put a line right here because technically that doesn't count. We're going to do time after this. We're going to draw arrows. Here's what I mean. I'm going to say how fast or what's going on in 3 seconds. Okay. So this arrow doesn't count for these 3 seconds. So I'm going to do 3 more beyond that. So if I go 3, well, this says this number here, if you remember, means that velocity changes by 5 every time. So instead of 3, the next time, I'm going to write 8 meters per second. The next time, I'm going to write 13 meters per second. And the next time, I'm going to write, oops, that should be a little bigger, 18 meters per second. The couple of questions that could potentially be asked here is how fast is it going at the end of that 3 seconds? That should be easy. That's just right here, 18 meters per second. Okay. The other question that could be asked is how far did they go in that time? You would not count this guy over here. You would just do everything right there. So obviously you could punch this into your calculator if you want. I should be able to do this in my head. What is that? 16, I think that's, oh my goodness, I'm doing math dumb. 31, 38, 39 meters. Okay, so it's traveling 39 meters of distance, and the velocity final at the very end is 18 meters per second. That's how you do an arrow diagram with acceleration. Good luck today. Now do your assignment.